You can see here, just another custom tooling for injection molding. We did some over molding with these products, and essentially had to pick up a bearing, put the bearing inside the injection molding machine, and then we had to injection mold the part, take the part out, load that part into another injection molding machine, and then it molded over it again, and then kicked it off into a conveyor. So with this, we had a few different technologies. As you can see, we did quite a bit of mechanical engineering, or I guess a little bit of mechanical engineering on this. Decent amount, though, actually. For all the constraints that we had, this tooling was, I don't want to say like extremely complex, but we had a lot of constraints to deal with because we had to get in between the tie bars of the injection molding machine. We had to be able to spin this thing inside the injection molding machine with a very tight space. Then they came back and told us that the mold floats. So like the part that moves, if you know injection molding machines, right? There's one of the surfaces moves, and they said that, well, it stops within about 1 inch every time. So like it floated around, like whenever it opened, it would be within 1 inch from where it was supposed to be, somewhere within 1 inch. They could, but when we're replacing with the robot, you can't have that. So one of the things that we did with this particular tooling is we put a laser on it, so that way we could take a laser measurement of how far the mold face was away exactly, and then that was able to give us the position that we needed. Also, we had like Cognex vision on here, which we utilized to detect that the bearing was actually placed into position, and basically did a verification check that it was in the proper position as well. So not only is it present, but is it within tolerance of where it needs to be placed at, so that way when the injection mold closes, it doesn't close up on the bearing and screw up the injection molding machine.